And we're live. Boom. Hello, everybody, and welcome. I am ArgandoV, and first I'd like to thank the Digital Overdose for hosting this event. And in this short video presentation, I'll be covering some quick data wrangling processes to parse through a complicated set of information with Linux. And this will be a little bit fast-paced, but I expect to convey some basics to get you started, so you know what to do if you're interested in going through the whole exercise on your own. You can, of course, contact me anytime if you have any questions, and you will find these exercises download link at the end, so you can get started and actually do what I'm doing here and a lot more, along with some extra resources and cool links and interesting reads about the topic. And let's get started. A little bit about me. I actually started my journey into IT, web, and cybersecurity just recently out of sheer personal curiosity around 2019. I'm originally a mechanical engineer myself, and 1 year ago was when my interest in this industry really peaked, and I started considering my enthusiasm and hobby about it could actually work as a driving engine for it as a profession. I've been breathing and eating all things ethical hacking, infosec, and cybersecurity since then, and so I'm really delighted to be here with you to share some cool and useful information. Also, I'm interested in Stoic and Eastern philosophies in my spare times, and I've also been playing guitar and bass for 22 years now, 10 of them professionally in a heavy metal band. And let's get started with it. Now, what are we actually doing here? We will be looking at an actual real scenario network packet capture file, which is containing malicious activity inside a network, and I'll be demonstrating an initial examination of it via the Linux command line interface, or CLI, and the search will be guided for us by some information and alerts triggered by a NSM, or Network Security Monitoring tool. And the tools that we will be using here are TCP dump and additionally some network miner or Wireshark, if you're more comfortable with Wireshark. Now, I know network miner is a Windows tool, but it's sometimes used in Linux distributions used for digital forensics. And just it happens to be a personal favorite of mine, so in either case, you can find all the how-tos in the reference section, as it is very simple to set up, but it can be a little bit tricky at times. And what we're expecting to gather in these exercises as indicators of compromise, or IOCs, are some malicious files being transferred to the system. So all you reverse engineers will go crazy with this one. Along with some confirmation of communications with some C2 or CNC or command and control remote system. And let's get started with the actual exercise. Now, what are we seeing here in this screenshot? It was provided as part of the exercise, and this is all the information we've got about the events. Now, Squill and how it works and what all this means is completely out of scope here, but we can actually use this information to guide us through our investigation, and it's really enough to start pulling the thread of our pcap file. You can actually find a little bit more information about how Squill and these ET-Pro rule sets, which you can see in the event message column. I will add a little bit more information about it in the resources section, so you can dive a little bit deeper into how all this whole thing works and how these alerts were actually triggered on all these rule sets. For this, all we need to know right now is what we're looking for in our pickup file, and taking a look at the event messages column, which is the 1, 2, 3, 4, 5, 6, 7, 8 column. We can see some pretty descriptive and specific alerts, such as portable executable downloads via HTTP, some Cobalt Strike beaconing, for example, some Meterpreter shells, and yeah, it's pretty enough for us to get started. This is really specific, so we are not expecting a lot of false positives. And for this exercise, I randomly picked three alerts, which I highlighted in red. So let's begin working on them. Also, another piece of information we have about the exercise is that the LAN segment is 10.2.8.0/24. So this is enough to get us started. We have actually some information about the local compromised system, which is 10.2.8.101, and you can see it in the squeal alerts. So let's begin working with those three alerts. Now, first, we need to read our pickup file. Let's fire up that terminal. And what would happen if, for example, I have this file in here, but what would happen if I just read it just as it is? It's nothing, right? It doesn't make any sense. So if you're familiar with TCP dump or not, you may or may not know that it's usually used for in-transit or live network packet capturing. But in this case, we're using it to actually read our pickup file. So I need to read it to fire up TCP dump as the super user. It may not be necessary all times, but it was in this case. And let's give it a couple switches. For example, we have 4 T's, which will mean that the timestamps of the packet capture will be human readable. Also, a switch will make the output in readable ASCII format. The N switch which will not resolve any address. Remember, we are looking at the squeal alerts as IPs and not as domains, so we need those IPs. And finally, the R switch, which will make us able to read our pickup file. And let's give it the argument of the actual file. Sorry, and let's just read through it. And let's see what we have here. And it's a little bit of nonsense, but I'm interested in a couple pieces of information, which is mainly about the file format. One thing I'm interested right now in is how it begins with the timestamp, then the protocol, then some additional information about the IPs, and whether it's for example, who is or who has a IARP request, etc. And another piece of information which I was interested right now in is this file, this format, if you can see it, which is the actual communication between machines, okay? Which is this format. We have our local IP, and it's interesting to see how the port is displayed, right? Just as if it was another octet. So it's 10.2.8.1.1 that, and then the port, and how it is communicating with this symbol, and then the remote machine with the same format, dot, and then the remote port. So with those two pieces of information, we can actually begin gripping through it. And back to this slide. We are now a little bit familiar with how the file format works for our pickup. And let's examine the actual first alert, which I totally randomly chose. And you can see the source IP, which is a local machine, and the source port, and the destination IP, and the destination port, and some information about it, which is interesting for us right now. The ET-Pro malware, and it's probably correlated by signature-based processes to Hansitor, which let's see what we have here. And just exactly how we know how our pickup displays our information, we can begin actually grabbing through it. We know our file format and how does it work, and we're looking exactly at that format. Here we have our local IP and how it communicated via the local port 49.755. Sorry, 49.755, and it's communicating in this way to the remote system, which is 215.5.229.12.80, the remote port 80. And let's give it some color to the output. Now, this is not always necessary, but it was in this case because I'm using actually WSL, which is not formatting it very pretty, so we will need it just for this time. Now, I will zoom it out so you can see it perfectly, but I don't think it will be readable, so just seek it with this for now. And what do we have here? We have these packets going on with exactly our search match, and something actually popped out pretty immediately, which is a post method for some very strange PHP file, which at this point we can't possibly know what it means or what it does, but we should definitely save this information as it is, as a piece of information for further analysis. And why not? Let's isolate it a little bit further and pipe it some more grep and search it just as it is for PHP. Give it some color. Get some. Okay. Now we have here some useful information which we should definitely extract. And let's actually see some context about this same packet. We will give it a little bit a couple switches to our grep command. And what A means is it will display after this search match. It will display the next 10 lines after this match. Let's give it the same switch for both parts of our grep commands, and let's see what we get. Okay, so now we have some context. Let's ignore this one because it's the next packet. But what is interesting here right now is the HTTP header, right? So we have this information, which is our unknown file at this time, but we have some user agents, some host, which is definitely interesting for our further analysis. And we actually also happen to know some things about the domain controller. We have here the domain, presumably this is the local user, Bill Cook, and also we have some information about the local machine, which is a Windows 10 with 64-bit architecture. And that's it for this alert. And you can see actually the same information, just printed beautifully. And let's save that up and move on with the next alert, which will be a little bit easier. Let me clear this up and let's start gripping through it again. But now we can actually see that it's the same communication, but in reverse. So we're actually expecting some confirmation of download, hopefully, or not, maybe. You can see it's the same order, but reversed. So let's work with that. 10.2.8.101 port 49757. Color always, and let's see what we have here. Nothing. Okay. There must have been a typo here. If you can help me out with that one, because I don't know what I did. 10.2.8.101 that 49757. If you can spot it, you can actually help me out in here, because, okay, let's work with this. Okay, it's just the same formation, just I omitted the local IP. So what we're expecting here is some actual confirmation of download, hopefully. And what do we have here? Some HTTP 200, which means actually it was confirmed. And that's another piece for our previous alert, and we can save this up for further analysis, because we have some confirmation of the download. No, you know what? Let's grab it again to see some useful information about the 10.2.8.101 port 49757, and it's communicating to the remote address, which is 8.208.10.47 port 80, which is interesting. And let's see what we have. I was looking at the confirmation before, but it's actually the same thing. This is what happened before what I did before this, and we can see some get requests, and yeah, we can see some strange binaries being fetched over the network. And we should actually definitely save this information, because this will be really important in our investigation going further, and expect a little bit more about these files. But for now, let's save this information as I highlighted in here. And for the file confirmation, we can see that it was actually with some response from our remote server, and that was our third alert. Now, what I can already hear you questioning is that can we retrieve those suspicious files? And turns out, yes, we can, and definitely should. Everything after this step should be in an isolated environment, and as an extra layer of protection, we will be using Linux. I used Kali Linux, which is definitely not necessary, but it was convenient in this case. And I used it to download some Windows malicious binaries from this pickup file. And in theory, they shouldn't be able to run in our system. All right, let's see how the whole thing looks. We have some final information. We can see some tabs working in Network Miner. I run it with Mono in Kali Linux, and you can see the hosts tab, the files tab, images, messages, in case you can see some SMTP traffic going on, some credentials, sessions, DNS traffic, and what did pop up immediately was our strange executables. You can see the octet string, which is a strange file we didn't look at, but that basically means it's an unknown file extension. And let's see what we can do with this executable. We can actually retrieve the files exactly as they travel to and from the system, and have some very relevant information about the source host, for example, which is the 5 column in the Network Miner interface, and along with some timestamps and other pieces of data, for example, the frame number in the first column, which will be useful in a further or more useful investigation. And now, as you can see, we can actually download the binaries as they traveled. But before going crazy with malware reverse engineering, we can extract the hash of our strange files and look them up in VirusTotal to basically confirm our suspicions. Let's see what we have. You can see the file's hash bin has been already detected by 57 out of 70 security vendors, which is pretty conclusive for us, and that's partly how our network security monitoring tool did the detection, which is signature based. So we have definitely some confirmation of malicious files being downloaded, and this was just an example of one file, but you can definitely work out the whole exercise and the whole traffic and the whole lines for the pcap file. And if we're using the CLI and in Linux, why would it be necessary if we already have some automated graphical user interface or GUI applications? Well, 3 reasons for that, mainly because we now know exactly how pickup files are structured, and we now know also the ins and outs of them, and now we have a deeper understanding of how any GUI of our choosing works. And also, if we decide to monitor the activity on our networks, a GUI packet sniffer can become a little bit heavy after some time due to the big load of data being transferred to and from the system. You can just run a Wireshark capture for 1 hour, and you'll see what I'm talking about. And the third reason is that sometimes GUIs are not available in our environment, such as in remote servers, if we are doing some troubleshooting or routine checkups. And that was pretty easy and pretty straightforward. Now, this presentation only scratched the surface on data wrangling and CLI, digital forensics or incident response processes, but I hope you got interested in it, and I really urge you to follow the full exercise. And before ending this talk, I would like to express some really gratitude to the guys at Republic of Hackers. It's a great ethical hacking community, and it's really a pleasure to be a part of it. Also to the staff at Digital Overdose Conference for hosting this event. Thank you all for your support, both for the speakers and for the community. And you can also see and download the exercise and the slides at my GitHub, which soon will be added with further information and some cool resources and reads and videos and whatever you need. And you may find me also on Twitter, Discord, and LinkedIn. And if you have some questions about it, just let me know, and I'll be happy to help. Thanks a lot for watching, and I hope you've enjoyed this talk. Goodbye.
We do have a few questions if you're up for it.
Yeah, sure.
Yeah, okay. So I guess I'll kick it off. So we have a question from Gogothis. Have you happened to use Snort or Suricata at all instead of a Squill for monitoring?
I'm not really familiar with how those processes work, but we know Squill works along with Snort, and Suricata is just another tool that we can use instead of Squill. But yeah, it basically works along with Snort with some signature-based network detection capabilities. Definitely.
Awesome.
Nice. There is more questions. How do you track your IOCs? Do you use tools like FireEye's Redline?
For this time, it was a quick exercise to extract some useful information, but sure, you can combine it and do some integration with some more robust softwares. Yeah, why not?
Awesome. Have you ever had to do some of some analysis like this in a headless environment where you only had a terminal and that was the only thing you really had to work with?
In this case, we can, for example, if we have a remote server and it's doing some packet capture with TCP dump automatically, and if we connect to the via SSH, we can do some actual quick checkups via SSH instead of downloading the whole PCAP and analyzing it in our GUI environment, right? But I think this is only useful if we, like in this case, know exactly what we're looking for. So it's a complicated answer to that question, but in this case, it was completely necessary and useful.